everybody. Welcome to the TEConnect Podcast. I'm John Martin.
And I'm Dean Reverman.
Dean, scanning has come a long way in our life. You and I are old enough to have kind of experienced a lot of changes in technology over the years, right?
This is true.
We may not want to claim that sometimes, but we have.
But been around the block.
Yeah. Mm-hmm. So like scanning technologies, like I think of like grocery stores.
Yes.
And in the old days, it was just those big pass-through scanner things that sometimes they were ringing it 5 or 6 times. If the barcode wasn't
work.
Yeah, if the barcode wasn't perfect, didn't work, and then they got to punch it in.
Yes.
Now it seems a little more sophisticated.
Yes.
It's a little more easy to just, you get your self-scanning.
Yep.
You might have a scanner gun that they're using.
Yeah, I've turned out to be a pretty good scanner myself.
There you go. Yeah. It's pretty quick and easy to do now. But you got presentation scanners now. You've got mobile devices now, though.
Yeah. Well, that's just it. They're everywhere now.
These things are equipped with some of the most powerful cameras on the planet now.
Yes.
Which kind of fits into the whole scanning technology thing, too.
It does.
That's our topic for the day. We're going to talk a little bit about the optics of scanning or scanning technologies, where things are going, where we are now, what to expect in the future, how it might kind of impact some various industries in our channel. We have Bruce Scharf with us today from Code. He's going to talk to us a little bit more about this topic. We're going to get into kind of a history of the scanning technologies, probably better than what I explained right there.
There you go.
We're going to talk about how these smartphones are kind of impacting the business, because people may want to try to use those instead of using purpose-built devices.
Yeah, but there's issues there. Yeah,
that's right. We're going to talk about what kind of scanning technologies he's excited about, what he's keeping an eye on, some of the freebie crap that's out there that is probably not as free and useful as you think it's going to be, and where we go from here. All of that, plus our usual what's tech connecting with us and value to the VAR. It's time to plug in and get connected. All right, as I mentioned, our guest today, Bruce, is it Scharf or Scarf? I forgot to ask you before the show.
It's Scharf.
Scharf. Okay, I got it right. I figured I did. He is the VP of Products for Code Corporation. Bruce, thank you so much for joining us today. Tell us a little bit about yourself and kind of how you got into this world of code and scanning and optics.
Okay. Well, thank you for having me. And I guess my history is I go back. I'm an optical engineer by trade. So that was my education. Worked at the track, trace, and control industry, basically barcoding for most of my career now. And it was kind of a great combination. It was that renaissance, if you will, of optics in imaging. As you had mentioned, cameras have come a very long way very quickly with the introduction of smartphones. So it's been a fun ride.
No doubt.
Yeah.
Okay, so optical engineer, like we always talk about the fact that the people we have on this show are better experts, obviously, than anything that we can ever be.
Yes.
I think we hit the nail on the head with this one.
Yes. Optical engineering, not in my realm of expertise,
no,
for
not
sure.
at all, which is why we're going to lean pretty heavily on you for this conversation.
Yes, it's all you, Bruce. No pressure.
That's right. We're just going to kick back, just talk about what you want to for the next hour. So let's start off then with kind of a hinted at this history of scanning technologies and kind of
how did we get here?
Yeah, how did we get to where we are right now? So give us your kind of a rundown of where we've been and where we are right now.
Well, it did start, I think sometime in the 70s with that first pack of Wrigley's gum that was scanned. I believe it was someplace in Ohio.
Yes. It was a store in Ohio. That's right. Yep.
Exactly. So anyway, and that was typically a laser just being swept across the barcode. And that worked for many, many years. And then eventually the one-dimensional imagers came out, which was just an array of photo sensors that could take a picture, if you will. That worked for a while as well. But then when people wanted to increase the amount of information that was presented in the code, the barcodes got really, really long. And so what we had to do was invent those two-dimensional codes. Well, once that happened, then you needed that two-dimensional sensor, or basically a camera. And that worked for a very long time, and it still works today. It's just now we can do an awful lot more things with those cameras, specifically with the smartphone cameras, because smartphones have really driven the performance and quality of those images we get now.
And so really, you feel it's complicit, the fact that everybody has this camera in their pocket and the ability to do that has had kind of a dramatic effect on where you sit from an engineering standpoint on things that are being developed and how they're being used?
Yes. So a lot of stuff that you couldn't even consider doing, really, really small codes that you suddenly can read, to, codes that are very far away. There's just a whole bunch of opportunities now. Multiple codes in the same field of view, because you can have a large field of view. There's just a lot more things you can do with that camera technology.
And I guess, does that start getting into 3D? You hear the term 3D codes, when you get into QR codes, stuff like that. I think everybody has a grasp of 1D and 2D barcodes, but 3D, it's not really a three-dimensional code, right?
It's not a little box sticking out the back of the code. Yeah.
Little box that's got, texture to it and stuff like that. It's not that at all, but is that kind of where you're going, or because you can pack a lot more information via the optics?
Well, it's interesting you should mention that. And one of the things I was going to talk about, one of the interesting technologies that I see out there in imaging is LiDAR technology. And yes, there is such a thing as a three-dimensional code where you can have the depths of something represent additional information. So it's not only light and dark, but now what is the depth? And with LiDAR, you can actually start measuring those depths. Now, it's not there yet because LiDAR is currently really focused on the automated, the autonomous car and autonomous vehicle market to measure distance. But once you are able to measure that distance, it's probably only a matter of time before the resolution and the sensitivity says, yes, you could probably do a three-dimensional barcode.
Yeah. I like how when you were talking about kind of the history and you mentioned and that worked for a while, and that worked for a while, and that worked for a while, because isn't that what progress and technology is all about? Is you get to that point where at some point you got to go, all right, this just isn't working with what we're going to do anymore. And I think in this particular instance, what we're talking about here, it's all about data.
Yes, information.
We're such a data-driven world and an analysis-driven world, and we want to have as much data at our fingertips as possible. And I think, because I know we think of barcoding, we think of either supply chain, or we often think of grocery retail. And I know in the grocery world especially, how important has it become to be able to get as much information as possible about a product, either on the consumer side of things to know the ingredients and nutritional information, or on the supply side of things to identify, how much you have, if it's past its use by life, all that kind of stuff. So yeah, so much data. Yeah, eventually barcodes would have been just sticking off the edge of a product, half a mile long. If you kept it the old way, you had to make some changes there. So then let's talk about this idea that that barcode scanning has typically been the task of these kind of dedicated readers, but as we've talked about already and mentioned several times, these modern smartphones, modern devices have these increasingly sophisticated cameras that can do amazing stuff that, even just leaps and bounds over 10 years ago, cameras did. Yeah. How is that kind of changing the way you and Code are approaching selling scanners and talking about imagers and dedicated mobile devices? Because I'm sure you encounter plenty of people that say, well, my phone can do that, right?
Right. But is it overkill, right? If you have a situation where you just need to read a code and put it into your ERP system, to track your inventory, as you said, then do you really need all of that power? And the answer is probably not. And one thing that you have to look at as well is it is mobile, which is good, but that means it can also sort of grow legs and walk out the door, which can be bad. So it's trade-offs that you have to do. So it's very application specific. Generally speaking, if the code is coming to the scanner, it's usually a dedicated scanning system, and that's the best approach. If you have to go to the code, then you generally would want some more of a mobile solution, and possibly a smartphone or a smart camera would be better there.
What are some of those applications, though, that you're seeing an increased need for data? I mean, because John, to your point, I mean, it's gone beyond the grocery store. I mean, the use of in logistics, honestly. I mean, you're starting to see it in QSR and restaurants for menus, doing quick links and stuff like that. But, there's a need for a little bit more information there. Healthcare, of course, is one of those verticals that continues to boom in the whole barcoding world, but there's some demands there too. And I know Code's very heavily involved in the healthcare industry. Maybe talk a little bit there about what you're seeing there and how it affects you from a product standpoint.
Right. So you're quite correct with the electronic, health records now, where you have all of the data of everything that's been, done to you in your health records. You need that increased information, and basically creating a comprehensive record of your past health history. So barcoding is one of the easiest ways to do that. You scan the medicine that you were just given, the test that you were taking, any sort of blood work that needed to be done. It's just so much more efficient to automate that and to have the results automatically uploaded into the electronic, record, rather than having them printed out and then having, the doctor read them and then someone transcribe them into a system. It's just made things a lot easier.
But
more accurate.
There you go. Yes, and accuracy is obviously very critical,
especially in healthcare. Yeah.
Oh yeah, a little bit. I want to go back to LiDAR real quick, because I think that's kind of a fascinating technology, and I would love to get your input or help me understand a little bit more. So you can get so much information on a 1D barcode, right? Well, depending on the length of it, of course, right. But in reason.
How much time you want to spend scanning
right.
it? Yeah.
And then you got 2D barcode, which you can stuff more information onto that. How exponentially more would LiDAR, do you think? What are we talking here, Bruce? Is that 10 times more information that you're going to be able to get on that QR code once you can have that depth, or is it going to be that kind of revolutionary, or is it even more? What do you think?
It will depend on the application, and as I mentioned, the accuracy of the LiDAR and the sensitivity is one thing, but at the same token, you don't want to have an object, say your candy bar or whatever, and then you have this big thick thing sticking out on top of it because you have, this piece of plastic that had to be etched at various ways. So I think it'll probably be in the 2 to 3 times as much when you look at direct part marking and that sort of technology, where you just do a little bit of an etch on metal, or you dot peen apart. I think if you can vary the depths and have, say, 2 or 3 different levels, I think that'll probably be the most practical.
And we're talking about something that would be at almost like a very small, like maybe not microscopic, but an extremely small level where you're not something that's going to be super visible, right?
Correct. Okay. Yeah, that's a very nice application as well. When we talk about the camera technology and getting more and more pixels, that allows you to, do smaller and smaller codes and still be able to decode them. But at some point, we have to remember that the real application of those cameras are for taking pictures and video and, interacting visually. And at some point, you're taking a higher resolution image than your eye can perceive. So why would you spend the cost and the energy to do that? So I think once the cameras get to that level of resolution, then we're going to see, because there's more need for more data continuously, then we're going to need to do some other things like, 3-dimensional codes, those sorts of things.
Yeah.
Makes sense. Yeah. So you've talked about LiDAR, already. Are there any other types of scanning technologies that are kind of, in development or coming down the road that have you really pumped and excited? I mean, as an optical engineer, I'm sure this is the kind of thing where you pay attention to this stuff as it happens. So what's got you geeking out right now?
Let's see, geeking out, obviously the augmented reality aspects of the scanning technology, where you look at a scene and a data closet, and you open it up and you can actually see what components may need to be replaced, preventive maintenance, all of that stuff is presented to you, usually via a record that's stored in a barcode. Could be RFID, but I think that is exciting. I do also like the fact that the cameras now on the high-end cell phones actually have multiple cameras, and then they stitch together, if you will, an image that has a huge depth of focus. So that's a really powerful tool as well. I remember in the old days of scanning, as you mentioned, when you tried to push it by the can of soda by the scanner multiple times to get it to read, there was always that you had to try to get it right in the sweet spot of the scanner. Now with this technology, there's the sweet spot is huge. And that's, I guess, both a good thing and possibly a bad thing, because now if you have multiple barcodes in what you're looking at, which one is of interest, right? And I think Right now, what people have to do on the smartphone anyway is they do the tap, right? This is the area of interest that I have, and that's where the phone focuses its attention. Well, again, with LiDAR, there's a possibility, and I don't think this has been demonstrated yet, where you could actually do eye tracking a lot more accurately. So then when you're looking at the image, if there's multiple barcodes, you just look at the one that you're interested in, and the camera will be able to tell that automatically. So that's got me kind of geeking out as well in terms of not having to do the double tap to focus, where you're interested in on the camera.
Yeah.
Those are some areas.
And I think that what I've seen on the AR side, going back to the AR, and if you can, somebody can visually, let's say you have a stocking clerk or whatever that's going through the grocery store and restocking, and they focus in on the barcode of the empty product or whatever it is, and that instantly looks up how many are in the back or something like that. I mean, that's the kind of efficiencies, I think, maybe where you're going, Bruce, where, when you combine some of these technologies with what is happening in optics, that's cool stuff. That's the ability to really kind of take the whole thing to the next level with augmented reality that is based on some of those things that were traditionally around, barcode scanning, but enabling that whole process.
Yeah. I'm really fascinated right now too by these apps, and Amazon is a big example that I can think of because I've used it many times, that kind of do almost the inverse, where instead of presenting something to you, like showing you something in the AR field, it's more of, hey, take a picture of something and we will be able to identify what that something is and give you and show you something. So like, for instance, a couple weeks ago, I wanted to get a new paintbrush to seal my deck, and I had my old one, and it was all frattered and frattered up and everything, just not in good shape anymore. So I grabbed Amazon and I was like, I don't know exactly what to look up for this because there's no barcode or anything on it. I was like, oh, they've got that little app thing. You can just take a picture, and this little star field almost appears and shows dots.
Oh, everywhere. I have not used this yet.
Yeah, and it will literally find that in the store, or at least find something similar. Like, it couldn't find the exact one, but it was like, hey, here's 6 other paintbrushes. Where I've really seen them use it also, I think it's when I discovered it, was a couple Christmases ago. We got their toy catalog. And when you're going through the toy catalog, you can literally just open up your app and turn on the camera portion of it, and it will scan the image in the catalog. And it's not like it's the barcode or anything. There's no QR code there. It's literally looking at the image itself and takes you directly to that product link in their store. To me, that's fascinating. I love that you can do that.
So Bruce, what's your take then on the back end? So the optics are one thing, the camera technology, but in order to enable what you were just talking about, that's some software.
Oh yeah.
Figuring that out in AI. Is that keeping pace, with the camera technology at this point?
I think it is maybe a little bit behind. I think it's one of those stories of, you first have the PC, right? It gave you more memory and faster processor, and then the software would use it, and so then they had to create more memory and a faster processor. So I think they're symbiotic, and so I think that the imaging technology is required first, and then depending upon that, the software and the AI and the deep learning can take advantage of that and push the limit, and then that will drive where the next generation optics goes. That could be one thing that continues to drive the resolution of cameras up, because even if the human eye can't perceive it, the AI and the deep learning can. And, maybe 50 years in the future, the barcode will be gone, because during production and inventory and everything, you just see the object. And because, like snowflakes, no two are alike, regardless of how good production is, no two are going to be exactly alike. You can probably uniquely identify them, but that's a long way off.
Yeah, there's a lot of people that just got panicked when you said, if the barcode goes away, when the barcode goes away someday. But to your point, you got to move forward.
Well, it's just going to be different. Maybe it's 40 or 50. I don't know what it is, but that's so true. And I was thinking to myself as you were talking, well, of course, the camera technology is just going to keep advancing, right? I mean, just go back to the $6 million man. I mean, everybody wants the eye where they can zoom 2 miles away and see with great detail whatever detail they were looking for.
The next
there.
camera will be us.
Yeah. But the software needs to be able to, manage that and consume the information and present it back to us humans in a meaningful way.
Yeah.
Right.
That's where things get tricky, I think.
Yeah.
That's true, right? The next thing is not going to be wearables. It's going to be implantables.
Mm-hmm.
Right. Yeah. Yeah. But I really do think optics is going to be one of those that is really going to just keep moving forward very fast pace.
Yeah, definitely. Well, Bruce, let's talk about we've bandied a lot about the idea of like our actual smartphones, the consumer devices that have all these fantastic cameras. I saw a roll off. What is it? The iPhone 13 is the next one that's coming out or is coming out, and they're showing like the rack focusing and all this stuff. And like
you can film a movie.
Yeah, I'm not even a photographer. I mean, they were already filming movies, but now
be a director of photography.
You can do like the some of the legit camera work, and tricks or whatever there. But, I did a campaign with Code a year or two back where we were focusing on, talking to healthcare about Cortex Decoder. And, one of the talking points that was in that ebook when I was doing my research about it was that there are hundreds, maybe thousands of free barcoding apps that are out there that you can use on a personal device. But, and this is part of the reason why you guys created Cortex Decoder, is an understanding that may not be good enough for what they're using there. So tell us a little bit about that. Like, if someone's thinking like, well, I can go get free apps that do the kind of scanning that I need to do, or that can pick up barcode symbology, that's good enough, right? Why is that not the case?
Well, I guess there's two adages to sort of describe that. The first one is you get what you pay for, right? So, the speed of which you can decode, the number of symbologies that you can decode will be limited. The speed will be slow in the free apps typically. And you may not be able to read damaged codes, or oftentimes even worse, you wind up with a substitution, meaning that it decodes what was not encoded, and that can be, a very bad thing. So first adage, you get what you pay for. And then the second adage, which you alluded to a little earlier, which is there is no such thing as a free lunch. So while it may be free, you need to wonder, well, what are they collecting? Is there some sort of analytics? Are they copying the data that's being scanned? Are they, doing something? And what is, what is in it for them? So there are free apps out there, but I know one in particular where it was implemented into a product and it actually contained malware. And some, tens of thousands of devices were infected. So be very cautious, I would say, about using, those free apps.
That's it, Bruce. And I'm glad you brought up the last one there, because I was going to read that article that it just happened in early 2021. One of the most prominent cases of barcode scanning app containing malware occurred. And so this popular barcode scanning app, they didn't name what it was, but it infected 10 million Android users. Wow. And what it did was, the barcode scanner started displaying ads that would then open up the user's default browser, even if they didn't mean to do that. And it started inviting them to download other, browser updates, which was just more malware going on to it. Google caught on to it and they eventually shut it down, but not in the case of the 10 million people, 10 million app users that were utilizing it. So that's a really good point, especially in the Android universe that is not quite as locked down, obviously, as Apple is. You got to be careful, but as solutions integrators, you also have to make sure your customers are aware of this type of thing. I mean, who would have thought that, right, Bruce? I mean, the malware one is like, that's a huge alarm if you ask me.
I would agree. To me, that one's the number one. And then the number two is the quality and the risk of a substitution and getting the wrong data.
That's it.
Yeah, again, going back to healthcare, which is where Cortex Decoder kind of fits in. Like, that's a place you just don't want to mess up.
Oh my Lord!
Like, you don't want to give the wrong type of medication. You don't want to give the wrong dosage of medication. You don't want to record that somebody got something when they didn't, or God forbid a test result or something. That you go call somebody up and say they've got cancer, and in reality that was someone else's result. That's the kind of stuff that if you're playing loose with your technology can go down a bad path.
And can you imagine the headlines in the newspaper if you implement a solution that has one of these whatever, I'll just call it an unvetted barcoding scanning app in the healthcare environment, and come to find out that it's been extracting that data and selling it on the dark web or something. Oh my Lord. Yeah. I mean, forget it. You have to be protective there.
Yeah. Well, Bruce, let me throw you sort of a little curveball. I didn't have this on the cue sheet, but, we talk a lot. Obviously, our industry is built on purpose-built devices, I know, that we do have people that play with, again, like Cortex Decoder with software and some stuff that can be used in conjunction with a personal device in order to, kind of bump that up to where a purpose-built might be. But, a lot of our VARs live in the mobile computer world and the scanner world. And, how are you having those conversations with them? Are any of them coming to you and saying, hey, I'm a little scared because I keep seeing these consumer devices getting better and better, and the cameras are getting better and better. I'm worried people are going to start turning away from purpose-built devices. Is that happening? Are you hearing that at all?
We're not really. So there's clearly, the purpose-built devices will always probably perform better for that intended function. It's, the mobile smartphones are still primarily, they used to be a phone that would take a picture, but they are really primarily designed around, video and photos and, texting more so. I don't know that anyone really has a phone conversation on.
And now they're just a computer that may make a phone call if you feel like it. If you're into that sort of thing.
Voice? What's that?
Yeah.
Yeah. That's go ahead, Bruce. I'm sorry. Go ahead.
Built devices still have a place. Yes.
Yeah.
Oh, I definitely think they do. And to me, I'm not afraid of that because you're getting bigger market growth when people utilize consumer type devices, because I know, and statistically I think this is proven, although I don't have the statistic, and no, it's not bro science, I really think this is correct, and because you can look at some use cases. There's a large box home improvement retailer out there that implemented consumer grade devices, bought tens of thousands of them to enable their associates on the floor. Gone. That didn't last very long. They went to purpose-built devices. Now, I just heard that Walmart announced that I think they're implementing 800,000 Samsung devices to enable their associates on the floor. I'm really interested in that one because it's not a purpose-built device. They're using a consumer brand device, and I'm wondering about that play. But kind of where Bruce or what I would say is that I think that even if you lose a deal, if you will, to a consumer grade device, stay with it.
Yeah, hang around.
Hang around, because eventually they're just not built for the environment. Period.
Or even the life. I mean, how often have you had to change phones?
It's not what it's designed to do. And I think more and more actually, society. It used to be kind of cool to talk about. Oh yeah, well my phone can do so much stuff. But if you're a worker in an environment, you don't want to have to deal with all the things that can go wrong on your consumer device and trying to get a purpose-built device. I know that's what we preach, but the rest of the world is slowly going through the process of understanding, this thing's pretty whiz-bang as it deals with me as a person, but me as a worker or trying to get stuff done, let's go purpose-built.
Yeah. And beyond that also, and we've talked about this when we've discussed Android before, and the idea of being able to have control over what all the devices that your people are using are doing.
Oh, yeah.
Or you give them a bunch of personal devices that they can use as personal devices too, if they wanted to. Then you have just a hodgepodge of people that are doing different things, downloading different types of apps. Maybe they're upgrading at different times to different types of software or different OSs. It's too much of a headache. You don't want that. You don't want the potential calamities and liabilities that could come out of that, because you've got 50 workers that 25 could be using this version, 20 this version, 4 of them have never updated at all.
IT nightmare.
Yeah, exactly. And the last one lost it down a sewer drain and didn't tell you. Who knows?
Right. Yeah.
So, well, Bruce, then let's wrap up. I think we've kind of talked a little bit about this and hinted at this already, but where do you think that scanning technology is going from here? What's next? What should we be thinking about when we look ahead 5, 10, 15, 20 years?
Wow. So 5 years, the short term, I would say we're going to see higher resolution. We will, I think, see that augmented reality and where those applications come into play. When we talked a little bit about the 50-year plan, where maybe items are identified just by themselves, that deep learning and that AI will be taking the image and working with it more so than a barcode or a QR code. So I think it's going to be a fun ride.
It will be, and you're starting to see a little bit of that. The last one there. I mean, I thought I was reading an article on a key or a robot that's being tested in a retail environment where you just walk up, because in the home improvement store is the use case, right? How many times have you walked in, whatever, you got to repair your toilet and you've got the part that you need. So you walk in and you go back to the plumbing. I need this. But that person's not there.
And you're looking at those giant shelves that are just filled with 6 billion items. Yeah.
But if you just let the camera capture it, and this is where you're going, Bruce, right? Where it recognizes the part just off the optics and says, oh yeah, we got something. It's where you were with your Amazon app. That seems intuitive that we're kind of heading somewhat in that direction. Yeah.
I'm very excited to see what we can finally do with AR. I feel like it's one of those things we've been talking about for so long.
Yeah.
And it's made little appearances, in video games and other random little places where people have found to use AR. But I really want to see and I know it's going to happen. And Bruce, to your point, I think it is going to be in the next few years. Somebody's going to figure out a way to make a practical use for that's just going to start changing the game. It's going to open the doors and everybody's going to go, man, we can do that too.
Absolutely. I think the form factor isn't going to be as sexy as it was rolled out initially. No. Like Google Glass was basically glasses, nice glasses, and they tried to pack a lot into it, but it just didn't work. Whereas the reality is, I don't know, I'm going to call it a COVID, the shields that people were, it's just the piece of plastic that wraps around your head. Yep. That's probably a little bit more applicable to how we could AR that right now.
Yep.
And you need a battery pack, and it's not sexy, and you probably need a cord going from your headset down to a little mobile device to do some of the computing power there. But
that's okay. We'll get there. Eventually it'll just be a chip in our brain,
Well, yeah, we got to start here with this, and then we can laugh 30 years down the road. Oh, remember those big face shields you had to wear?
Yep.
Yeah, well, that's how our AR looked in the 2020s.
Exactly. Just like the people who laugh at us when we talk about landlines, So. All right. Well, hey, before we get to our recurring segments, I want to, as always, thank our sponsors of TEConnect. We always appreciate your support. Thank you so much to Code for sponsoring a couple episodes this season and lending us Bruce today.
Yes.
As always, if you want to connect with us, if you want to tell us a little bit about, what you think about the show, if you have questions about scanning technology, topics that you want us to get to at some point, reach out to us. You can find us on Twitter at TEConnectPod. You can also email us, techconnect@bluestarinc.com. All right, so let's wrap up first with value to the VAR. And this is one of those ones where I feel like we've given you the value, a lot of it all along the way, sprinkled it in, but let's kind of package it up here. So Bruce, when we think about verticals that are really impacted by scanning technologies, I know we've talked a lot about healthcare, we've talked a lot about supply chain, retail, grocery, but maybe as you're thinking ahead to some of these newer technologies like AR, LiDAR, maybe eliminating barcodes altogether at some point in the future and just going with images. What verticals do you think are going to be most impacted by these changes as they come about?
So in the history, it was really you tracked something and you traced its pedigree, right? That was what barcoding did. Now it's getting into that, fourth generation manufacturing, manufacturing 4.0, that track, trace, and control. So now it's, looking ahead as to what we should be doing. And it's one of the things that the code talks about is, empowering intelligent decisions through data capture. So I think as the imaging advances, as we get more data from different sources, that really what we extract from that data is going to be an awful lot of value to the customer. So the value to the VAR is going to be looking at, not just the data, but the intelligence that it can provide us and the information to help us make decisions as to what happens next. So that to me is very exciting.
And that's a good one. That's forward thinking. That's where we're going. Certainly in the future. I'll throw on the table that one that I keep hearing getting talked about a lot around Blue Star and when I interact with resellers and whatnot. the whole concept of reshoring, right? And this is all around supply chain. Supply chain is just a disaster right now, right? So there's a lot of thought about bringing some of the manufacturing back here into the States, or reshoring it, as it's called. So, which is all well and good, but a lot of these small manufacturers, as you and I have talked about a lot, are still on paper or pencil or using Excel for a lot of their data collection kind of a thing. So, I guess I bring that up to say don't poo-poo the 1D 2D technology that's out there, because there is a ginormous universe that could really use that technology.
They're not even that far yet. Yeah,
they're not. And
baby steps.
If we're going to reshore some of this manufacturing, oh my gosh, it's going to be very complicit. And so when you look at it, I think that's why they're saying the global 2D barcode reader market is going to continue to grow at a pace of greater than 8% over the next couple of years. And I would say even more than that, if you really truly do bring a lot of this manufacturing back in, you got to be able to track and trace it, for crying out loud. So
I agree.
There you go. Yeah.
I think also we talked about healthcare quite a bit. And
that's a big one. Yeah.
I think, there's this world that we all have been dreaming of for, it feels like 20, 30 years now, of the whole electronic health record being a unified health record that follows you from place to place. Where I know in this area where I am here in Northern Kentucky, we're kind of spoiled a bit. We've got a healthcare system that kind of dominates here. So it's a little easier to be interconnected, when you move around from place to place. But in many places, people go to, one doctor for this, another doctor for that, a specialist for this, a hospital for that, and
different
none
systems.
of them, none of them are connected in any way.
Right.
And that can be very dangerous. You need to know what a patient has done in one place in order to treat them properly in another. And I think as we develop this scanning technology, maybe get a little better at it, hopefully that's something that can enable it. And there's a lot bigger picture, a lot more stuff that has to happen to get us to that point. But I think, as we improve the way we're able to scan and pull in data and track data and very quickly and easily grab information and attach it to, a person, their file or whatever, I'm hoping that makes that easier as you go down the road, too.
It certainly would be nice, wouldn't it?
It would. Yes.
Good Lord. Yes.
All right. Well, hey, let's wrap up, as always, with our favorite segment, What's Tech Connecting with You? This is where we get to talk about something from the world of science, innovation, technology. It's got our attention, caught our eye this week. Bruce, what is Tech Connecting with You right now?
A couple of areas. One, energy storage, and I don't mean batteries. There's a lot of stuff going on there. So keeping an eye on that. A little closer to home in the data capture. Believe it or not, more of an older technology, which is near-field communication. Been thinking about that a lot lately, and remember that all started with that old, tap your cell phones together to exchange, your phone numbers and your contact details, and that really didn't go anywhere. And now, of course, it's more ubiquitous with the tap to pay. But I really think that there's a way for some very interesting applications using that technology that can complement the barcode and the scanning technology that it's kind of got me thinking quite a bit.
I'm going back to the energy storage part. You've
talked about batteries.
I've talked about batteries. So if it's not a battery, help me out here. Where are we storing it? Like in limestone caves? But how are we storing it?
So there was a couple of them. They're kind of interesting. Obviously, the one that's been around forever is the whole water, right? You pump water uphill, and then at night you move it through a turbine downhill, right? But there's another one there's a large scale one where it's basically huge, I don't know if you want to call them concrete blocks, and a crane lifts the concrete blocks up with the energy, and then when it needs it, it lowers them down. Also takes a whole lot of space.
Gotcha.
And then the other one that I thought was kind of interesting is basically it's much more compact, but it uses a ceramic and then a whole bunch of basically toaster heating coils. And you basically superheat the ceramic. And then when you need the energy, the ceramic cools, and you have arrays of conversion cells that put it back to electricity. So
nice.
And who knows what's actually going to win, but
that's cool.
I like the ones that are maybe a little simpler and maybe don't rely on some exotic materials that are so expensive.
Yeah.
That gets back to the engineer and me. Engineers are real cheap. Right. So
there you go.
What's cheaper than gravity, by the way? I mean, come on. How do we harness that in? It's not going anywhere.
Hey, sometimes Mother Nature has the best solutions.
Yes, gravity. I love that. Yep. Anything gravity. All right, so I got one for you.
Okay, let's hear it.
In mouse experiments, scientists unlock the key to scar-free skin healing. I thought this was kind of interesting because I've got a couple scars on my body, through the years, being a kid and whatnot. But now researchers at Stanford have decoded the chemical and physical signals that trigger a particular type of skin cell that produces that scar. That I did not know, by the way. So it is a chemical type of a thing. But they've discovered a way to reprogram those cells, transforming them into another cell type capable of regenerating the tissue intact. So I'm telling you, we're going to be like bionic people. It's not that far away. Scars, no problem. Can you imagine now going into whatever the what do they call those surgeons that do cosmetic surgery? Yeah. Well, now we've got, instead of a chemical peel or something like that, you'd probably be able to have this reprogramming of your cells to wipe away those scars. But in all seriousness, that would seriously have an impact.
The scars remind us that the past is real.
Oh, fair enough. Yes.
There's a little music quote out there for anybody who wants to get that one. So I
was fascinating by that headline. I'm like,
I can see that being like a big deal for someone, like if you've got like, bad scarring on your face or something.
Well, like you were in a car accident or something like that.
Or something like that. There's obviously some amazing applications.
Yes.
But I could also see it getting down to the nitty gritty of like, this will be just another version of the facelift or, the collagen injection or whatever. Of just like, I got a little nick behind my ear back here and I don't like that. I want it to be perfect. Come on.
Make me look like whoever.
Right. But no, that's an awesome awesome.
I thought it was a pretty good one. Yeah. So what's TEConnecting with you?
All right. So, space is kind of a dangerous place.
Dangerous.
We all think it's
really
fun and
big.
cool, but it's pretty dangerous, all things considered. Well, it gets even more dangerous when rogue countries are blowing up satellites and you're in orbit, right?
What happened?
Russia blows up a satellite, creating a dangerous debris cloud in space. The field of debris may be passing by the International Space Station.
Oh, Lord.
This was actually from a few days back. So
yes.
Russia was apparently testing
out. Or did they blow up their own? Okay.
They were testing out a ground-based missile for destroying satellites, and they blew up one of their old satellites, I guess, that had been sitting up there for a while.
Okay.
And now, mind you, there were Russian cosmonauts on the space station while they did this. It created this giant debris cloud that apparently was moving rapidly around the Earth because it's in orbit now.
Oh, sure.
And there were they went into some emergency protocols on the International Space Station to kind of lock down, wondering if it was going to potentially impact the station. I don't think anything did happen.
What are these people doing?
I mean, it's like, first of all, like, interesting for them to be, trying this out. Like, what's the flex here? I don't know, but like,
we can blow up satellites.
I guess so.
Okay.
I guess that's what they're trying to show off. But like, it's pretty bold to do that when your own people are up there and potentially can be in danger because of it. So,
but they care for their people.
Yeah. Don't tell my wife about this. She's already said that if my kid ever gets interested in going to space, she's going to shut that down because she's terrified of the idea of anybody going to space and how dangerous they can
running into junk. Yeah, we've talked a little bit about space. It made me
think of that Gravity movie, the one that came out with Sandra Bullock years ago. That was all just debris that ripped up, and even this tiniest little, like just a little screw can be dangerous enough at a high speed floating around in space.
Going 17,000 miles an hour? Yeah.
Punch a hole in a space station. Yeah. So, space is dangerous enough.
Clean up the space.
Exactly. That does it for us. It is time for us to unplug. Bruce Scharf from Code, thank you so much for joining us today. We appreciate having you on.
Thanks for having me.
Until next time, maybe don't blow up any satellites before you check and see if someone else is around. And please stay connected. The CR2700 is Code's 4th generation Bluetooth 5 barcode scanner, combining nearly 20 years of market experience with new features to improve the workflow in any setting from medical to retail environments. Available in both light and dark gray, Code has taken their unparalleled scanning performance and stepped it up a notch, tackling even more damaged and poorly printed barcodes to keep your business moving. Additionally, the CR2700 is now available in a FIPS 140-2 certification option. This government validation of robust data encryption is yet another reason why the CR2700 is a market leader. To learn more, check out the link in the show notes or contact your Blue Star representative.